Hello students, welcome back to Excel Maths. Today we are going to be starting a chapter from Mechanics, EU1, and that's nothing but constant acceleration. So let's get started. What the objectives are. So we are going to be discussing about DT graph in this particular chapter, VT graphs. We will talk about constant acceleration formulas, and we will work on using the knowledge of what we achieve in this chapter, implementing in problems. Today we'll be focusing on the first one, understanding and interpreting DT graph, displacement time graphs. So displacement time graph is not a new thing. You would have done it in GCSE's physics also, as well as maths. If we see DT graphs, so we see all these different types of graphs, right? So either the one which is parallel to the x-axis, these are different types. And if you see, I just have divided them all in each cases. Let's talk about a bit of vocabulary about the same, like a terminology. So the displacement is always represented on vertical axis is for displacement and horizontal axis is for the time. Right, now these are the graphs you would definitely have seen in GCSEs. Today we would be adding a bit bit more in this, and we'll also add a new way to learn the same thing. So I'll show you how exactly all these graphs work. So the first graph you have seen, which was nothing but a straight line. So say for example, if I draw a straight line over here, we would be having a turtle just hiding in the pond. The water body is down there and it's a sand, the grass there. So we'll see the behavior of the turtle, right? So we drew a straight line which is very parallel to the x-axis, the time axis. So as you can see, the turtle is sticking to a particular location, same position. The time passes, the time is progressing, but the turtle stays there only. The turtle stayed over there, right? So this is how the first graph represents the stationary object. When the object is not moving at rest, so we get the straight line drawn. Say for example, we have two objects and they are not moving again. So if I draw another line there, let's see how it works. So we have two turtles and they both are staying, sticking to the same position respective to each other, and they are not moving, correct? So overall we can just conclude that if it is a line parallel to the x-axis, we would be having objects now moving stationary, correct? The second graph was, the second graph was like this. So if I draw like this, let's see the behavior. So the turtle starts moving, coming out of the pond, crossing the sand, keeps going and going and going, and reaches the grassland and disappeared. So this is what the behavior you have seen when the turtle was when the graph was like this. We sketched it like this. That means when we are drawing a straight line, the object moves. The object is moving actually, no? So these points, how did we draw this graph? We are just connecting these points. That is very basic thing, no? And each point represents a particular key parameters. Say for example, over here you took 4 seconds to reach 4 feet because it's the unit given, 8 seconds for the particular distance. So we have for each particular time interval, for each second we have some distance traveled. So this is what it shows the turtle moving. These dots, it is actually reflecting, but never mind. So this is like the turtle we have moving with a constant velocity. Okay, so I'll draw it back again, just give me a sec. So our graph was something like this. And what did we see? We saw that the object, the turtle, is moving. So whenever the question comes to find out the velocity because it's a distance time graph. We're not talking about the velocity. So velocity is nothing but the gradient of the distance time graph, right? Okay, now if I just draw one more line like this, what does that mean? We have two lines. The first one, the one towards the y-axis is steeper. Like this one is steeper as compared to that one. Let's see the behavior of turtle, and I think we would be having two turtles because two lines are there. Okay, so what do you think? The top one is the faster one, the bottom one is like moving and moving and moving, and the slower one. So can we say steeper the line, faster the object is? So if you have to show the difference of, three objects, like we have a race or something, and you want to represent the same data, same information in the form of graph, so you are going to be changing the slope of those straight lines. Let's see. We have three turtles. One is fastest, okay, ends up. The second one is faster than slower than the first one, and the third one is the slowest one. If you draw one more, okay, which one is going to be going to the one who loses the race? Obviously this one, the one closer to the x-axis. Closer to the y-axis is like steeper the graph is, steeper the slope is, faster the object will be, higher the velocity would be, right? Does it make sense? Oh, the last one, very slow. Correct. Okay, now let's remove them all. We discussed first two graphs. Now third and fourth. So the third graph, we have it like this. Let's see how the turtle behaves. Slower, faster than before. Yeah, its speed is increasing, no? Let's check again. So I'll draw the graph like this. Okay, let's see how the turtle behaves. So the speed is increasing, right? Correct. What's the difference between these two graphs? Let's see. What's the difference between these two graphs? Okay. So the bottom turtle is actually moving with the same speed, same velocity, but the top turtle was very quick, correct? We have two turtles because we are starting from zero. So we have two turtles, one is very fast, but the other one with constant velocity. So this particular graph is actually represents the constant velocity, but this one is representing changing velocity, like velocity is increasing, right? Okay, so overall we can say when we are getting the graph like that means the velocity is increasing. Now the last one, what if the graph goes like this? Let's see. Okay, keep observing, right? Oh, move. Very slow. So we've seen initially the turtle was moving, but the velocity is decreasing and decreasing. The motion, goes slower and slower. So yes, these are the four different types of displacement time graph we have seen over there, correct? When it's very horizontal, parallel to the x-axis, the object is not moving. When it's straight line, like this, the object is moving with a constant velocity throughout. For the third case, it is the velocity increases with time and the velocity decreases with time. So we have these four different types of graphs. Okay. Now, over here, we are going to be talking about the vocabulary. So there we actually have seen. So this is what it is. It is the slope. The slope shows nothing but the velocity. So the slope gives us the velocity of the object. Steeper the slope, faster the object is. So the object is going to be faster here as compared to that one. And they both show velocity. What about these these, like, give me a sec. What about these lines? This part of the graph shows no motion, correct? The object is at rest, no motion. This is also no motion. So yeah, so we have seen that the slope, which is the gradient, slope is nothing but the gradient, and gradient you know very well. The gradient gives us the velocity, and what else can we talk about? The same velocity is what? Just the rate of change of displacement, no? Okay, so now next we are going to be talking about average velocity and average speed. Average velocity is taking velocity. We know velocity is a vector quantity. Vector, and speed is a scalar quantity. Vector quantity is the one that has magnitude and direction both. Scalar is the one that only contains magnitude, no direction is specified over there. So when we have to find out the average velocity, we take the displacement from the starting point divided by the time taken. And if you have to find out the average speed, you're going to be taking total distance traveled divided by the time taken. Okay, now is the time to sit for a few examples and then questions from exercise. So we have the first example over here, which shows a graph for a cyclist. A cyclist rides in a straight line for 20 minutes. She waits for half an hour. Which part of the graph shows the rest time, wait time? Yeah, it's here, correct? This part shows the rest time, and these two, this one is velocity and that one is also a velocity, right? What's the difference between these two? So we can say for example, this is your native place, like your home, and 5 kilometers away you have a school or your friend's house. So you left your home, after 20 minutes you reach your school, you stay over there for a particular interval, and then you come back. So when you're coming back, so it shows the negative slope, negative gradient, the line like this. Okay, now what we need to do, we have to work out the average velocity for each stage of the journey. So for the stage, say for example, this is the stage 1, that is the stage 2, and this is the stage 3. So the stage 1, for stage 1, what we have to do, it is asking about average velocity. What the formula was, displacement from starting point divided by time taken. So let's do the same thing. Displacement from starting point, so 0 to, how do we check the displacement? We're gonna be, let me just remove extra informations. Okay, so if we just see, it is 5, 0 to 5, so like 5 kilometers divided by the time taken. The time taken is 20 minutes. So it would give us kilometers per minute, but we have to find out in kilometers per hour. So we will be multiplying by 60. So that gives us 23:15. So it comes 15 kilometers per hour, correct? Okay, now let's check for stage 2. Stage 2 shows no motion. So if there is no displacement, no velocity will be there. So that would be 0. Now for stage 3. Stage 3 is from B to C. So if I just remove everything, okay, and we have to focus to B to C. So from B to C, C is the end point. So 0 minus 5 will give you minus 5 over, what's the time taken? Time is 10 minutes and 5, like 15 minutes. Times it by 60 to turn. Why are we multiplying by 60 every time? To make it, to change the unit, kilometers per hour. So that would be coming well, minus 20 kilometers per hour. So this is what we get from all these three stages, and we get our A part done. B, write down the average velocity of the whole journey. So the average velocity of the whole journey, what it would be, because you started, when you are starting from a particular point and turning back to the same point, your average velocity is actually zero, because your displacement is zero. So what I'm trying to say for example, this was the initial point, the point you have started, and you come back to the same point. So displacement is what? When we talk about displacement is final point minus, final location minus initial location. Okay, when you have initial and final both same, so obviously it's going to be zero. When it is zero, your average velocity will also be zero. So B part will give us zero only, correct? Now for C part, work out the average speed. Average speed doesn't depend upon the displacement, but it depends upon the distance. So for that, we are going to be taking the total distance. So whether it was returning back to the home only, but you traveled 5 kilometer, and you were staying over there for like 5, 10, 20, 30 minutes, and then you came back. So your distance traveled is 5 plus 5, 10. 10 divided by your total time. It doesn't matter whether you were waiting, you were staying, resting, whatever. We are going to be dividing by the total time. So from 0 to 60 minutes, and there 5 minutes more. So 65 times it by 60. So that is 600 divided by 60. So it gives us, let's see what it gives. 600 divided by 65, sorry. So 600 divided by 65 gives us 9.23. Three significant figures. And this is what the final answer is. It would be kilometer per hour. Okay. So this is the first example we've done. So we will wind up our lesson for the day. It was moreover discussing about different type of graphs and what's the reason behind. I wanted it to be very clear, because whole mechanics depends upon these basic ideas. So I feel like now you are clear with the same thing. In next lesson, we'll be discussing some textbook questions as well as your practice book questions. So yeah, we'll be continuing the same thing. See you soon. Bye-bye. Take care.